All right, we got a nice short video for you today. So our last section is on estimating. And really, we're going to do some estimates with our graphs, with some of our data. So an estimate, as you know, it's like an approximate calculation. So for example, if I got some decimal that was like 3.874 or something like that, usually we'd round it to approximately 4, depending on what you're using for your information. Sometimes you might even round that to 5. Sometimes you round it to like 5s and 10s, depending on what you're doing, but you just make estimates with it. Okay, so let's look at some data. All right, so kind of like the previous day, we got a graph on the distance from a motion sensor. So our time is on the x-axis, like always, and our distance is on the y-axis here. Okay, and if you take a look at this graph, do you notice how it like cuts perfectly through every single square like that? Starting from the origin, it cuts perfectly just like that. So every time it goes 1 in the x direction, it goes up 1 in the y direction. So it goes 1 in the x, 1 in the y, 1 in the x, 1 in the y. It's nice and smooth like that, right? Anytime it's like that, we call that, so just basically the x is always matching up with the y, right? So when x is 1, y is 1, right? I can see right on this line there, when x is 2, y is 2. When x is 3, y is 3. I'm not looking at the dots, but the actual line, right? So when x is 5, y is 5 on this line. So x equals y. Well, when we actually write an equation for this, like a linear equation, so we actually call this, whenever we write an equation for a line, we always say y equals. So in this case, I would say y equals x, right? Because the y always equals the x. I just kind of flip-flopped them because it's symmetrical like that. So that would be the equation of that red line right there, y equals x, because they always match up. So just know that if it ever cuts like diagonally perfectly through there, that's the equation y equals x. So let's answer some questions from here. So first one, approximately how fast is the person moving? Explain how you know this. So approximately, that's why they drew this line in. This line kind of fits the data, right? So we don't know exactly how fast they're moving. I could probably calculate it if I used all this data, but I drew this nice red line in because it's kind of an approximate of the dots. So what would the speed be for that line? Well, let's think. In 1 second, you went 1 meter. In 2 seconds, right, you went 2 meters, right, on that line. In 3 seconds, you went 3 meters. So how could I describe that as a speed? Remember, speeds are known as like a rate. And our most common rate is miles per hour, right? Miles per hour. Well, in this case, we don't have miles and hours. What do we have? We have meters per second. Meters per second. So how many meters are you traveling each second then? Well, we said every every second you're going how far? 1 meter. So you're going 1 meter per second. So I might write that out. You're going 1 meter each second. And this is how we'd represent it. We'd say 1 meter per second. We have that we use the division bar for per, meter per second. So remember, per always means division. Okay, so I could just look at that line, that y equals x line that we have in. What about the next question? It says name 2 different half-second intervals. What does that mean, a half-second interval? That's like every 0.5 seconds, right? Half-second intervals. In which the person is moving more slowly than the rate you found in 10A. So we found that we were traveling about 1 meter every second, 1 meter per second. So can you go see from like 1 half a second to another half a second? So can you look from each, well, let's just look at our graph. If you notice in our time right here that each of these dashes is 0.5 of a second. So we're just looking from one dash to another dash. Where does it look like we're traveling less than 1 meter per second? Well, can you see it right away? If I look at these first 2 dots, this one is right on the line and this one is just below. So that's just a little bit slower than 1 meter per second. So I could say from 0.5 seconds to 1 second, right? That's a half-second interval right there, from 0.5 to 1 second. I actually moved just a little bit slower than 1 meter per second. So if I look, I didn't quite go up half of a meter in half of a second, right? So you're just kind of looking based off that line. That's why it's nice to have that line to tell. Well, it asked me to find two different ones. Can we find another one? Let's look. So I got these two. Is there another one where it doesn't look? Let's see. I see two that are kind of obvious to me, or one that's probably the most obvious. Kind of look up in this region right here. Do two of those dots look like it's a little less than 1 meter per second? I know a lot of people want to say these two just because they're both below the line. And I agree, that would make sense because this one is more below the line than this one, right? So you could say those two, that's totally fine. I might go with these two just because, man, this one's above the line and this one's below the line. So I know that that's a little bit less than that too. So I could also say from, what would that be? Let's go down. That would be 3.5 seconds to 4 seconds. So from 3.5 to 4 seconds. Good. And the last question, well, why don't we tell when they're moving a little bit faster than the speed that we found? Okay, so now we got to look which ones look like they're going, faster than 1 meter per second. Well, the first two I see, we said these two were slower. Well, these guys, right? This one's below the line and this one's above it. So it's got to be faster, right? Its slope is quicker. Like if I drew this line in, it's going up a little bit quicker. So that would be from what? From, looking at our graph, this guy's at 1.5. So 1.5 to 2 seconds. And do you see anywhere else where that occurs? Yeah, I think the next biggest one would be that very one right next to it, right? That one. This one's just barely above the line where this one's a little bit above it, right? So it increases a little bit faster. So that's from what? 2 to 2.5. So from 2 to 2.5 seconds as well. Okay, so it's all about just reading very carefully and going to look at your graph and make some inferences from that.